Consider the function f of x equals to e power cos 2x, where minus pi over 4 is less than or equals to x is less than or equal to 5 pi over 4. Find the coordinates of the points on the curve y equals f of x, where the gradient is 0. Using the second derivative at each point found in part A, show that the curve y equals f of x has 2 local maximum points and 1 local minimum point. Sketch the curve of y equals f of x, for 0 is less than or equal to x is less than or equal to pi. Taking into consideration the relative values of the second derivative found in part B. Find the Maclaurin series for cos 2x up to and including the term in x power 4. Hence, find the Maclaurin series for e power cos 2x minus 1 up to and including the term in x power 4. Hence, write down the Maclaurin series for f of x up to and including the term in x power 4. Use the first two non-zero terms in the Maclaurin series for f of x to show that the integral of e power cos 2x dx from 0 to 1 over 10 is equal to 1 over 149e over 1500. Okay, so for part A, we're trying to find the coordinates of the points of the curve y equals f of x where the gradient is 0. So what is the gradient? Our gradient is the same as dy dx, which is the same as f dash of x, okay? So our f dash of x here would be e power cos 2x dx. And by applying our chain rule here, our derivation of the exponent here would come down and become our multiple. So this would be minus 2 sine 2x, and then the derivative of e power x is e power x, so we just have e power cos 2x. And this is our derivation. And so we know that minus 2 sine 2x times e power cos 2x is equal to 0. Okay? But e power to anything, so e power cos 2x cannot equal to 0. We just have to remember that. And so we just choose the next one. So this is minus 2 sine 2x is equal to 0. And we moved minus 2 to the other side, so we would have sine 2x is equal to 0. So what are the values of x so that sine 2x would equal to 0? So our values of x, as you can see from this table right here, you will not have this table. You would have to memorize all the values here. So the values that can equate this to 0 are minus pi over 2, 0, pi over 2, and pi. And just to prove this, we can do, let's take this, okay? Sine, oh yeah, let's take 0 for example. Sine 2, 0 is sine 0, in which we can see in the table sine 0 is 0, okay? And let's take pi over 2. So this would cancel out, we would have sine pi, and here sine pi is 0, okay? And for sine 2 pi, as we can see over here, sine 2 pi is 0. But we have to look here. Our values have to be within minus pi over 4 and 5 pi over 4. So both these will not work. All right. So we are left with 3 values of x, in which we can use to substitute into our normal f of x, which is e power cos 2x. Okay? Now we substitute 0. E power cos 0 would be e power cos 0, which is, if I'm not wrong, 1. Cos 0 is 1, yes. E power 1, also known as e. Then our f of pi over 2 would be e power cos 2 pi over 2, in which our 2's would cancel out, and we'd be left with cos 2 pi. And cos pi is minus 1. Yeah, right here. e power minus 1, which is the same as 1 over e, according to the law of exponents, okay? So e power minus 1 is 1 over e. Then our f of pi would be e power cos 2 pi, which is e power 1, same as e. So that means our coordinates are 0, e, pi over 2, 1 over e, and pi, e. Okay? Next question, we have, using the second derivative at each point found in part A, show that a curve y equals f of x has 2 local maximum points and 1 minimum point. All right, so according to the rules, f of dash of x, when it is less than 0, it is not a local maximum. It is not a local minima, it is a local maxima. We have to remember this. Okay? F of dash of x, when it is greater than 0, it is a local minima. It's a bit kind of weird to get used to, but we have to remember that. So that means we have to find our f of dash of x, which is minus 2 sine 2x cos, e power cos 2x dx. And to find this, we can apply our product, as we can separate minus 2 sine 2x and cos 2x. Okay, so our u would be minus 2 sine 2x, and our v would be e power cos 2x. And by applying yeah, okay, so this would be minus 4 cos 2x, as this would go out here, and then the derivative of sine x is cos x, so we have minus 4 cos 2x, and our v dash would be minus 2 sine 2x times e cos 2x. Then our dy dx would be u v dash plus vu dash, okay? And here we would have minus 2 sine 2x multiplied with minus 2 sine 2x times e cos 2x plus e cos 2x times minus 4 cos 2x. Then we would be left with, we can just combine these together, minus 4 sine 2x e cos 2x plus e cos 2x times minus 4 cos 2x. Then we can factor out minus 4 and e power cos 2x. So we would be left with minus 4 e cos 2x, open bracket, sine 2x plus cos 2x. Now this would be our f of dash of x, okay? I don't know why it keeps opening that menu, but there you go. And now we can substitute our x values, which were 0, pi over 2, and pi, okay? And with this knowledge, we can do minus 4 e cos 0 sine, to 0 plus cos 0. And we would be left with minus 4 e cos 0 times sine 0 plus cos 0. And with this, we know that cos 0 is minus 1. Cos 0 is not minus 1, my bad, it's 1. And then sine 0 would be 0 plus 1. Then we'd be left with minus 4e. And since our f dash of x is less than f of dash of 0 is less than 0, that means that this is a local maxima. Okay? Then we do f dash of pi over 2, which is minus 4 e cos 2 pi over 2 sine 2 pi over 2 plus cos 2 pi over 2. Then we just cancel out all the 2's. We would be left with minus 4 e cos pi sine pi plus cos pi. Okay, and then cos pi is minus 1. Sine pi is 0, if I'm not wrong. Sine pi is 0. Yeah, sine pi is 0. Plus minus 1. Then we would be left with minus 4, 1 over e times minus 1, which would leave us with 4 over e. And since our f of pi over 2 is greater than 0, this is our local minima. Okay, then lastly, we do our f of dash of pi is equal to, what was it? Minus 4e, okay. Minus 4e cos 2 pi sine 2 pi plus cos 2 pi. Okay, and from here, our cos 2 pi would be 1. Our sine 2 pi is 0, and our cos 2 pi is 1. So we would be left with minus 4e, which is again less than 0, which means that this is our local maxima. All right. And we need to make our conclusive statement. So hence, 0 and pi are local maximum points, and pi over 2 is a local minimum point. Okay, accidentally scrolled down. All right, so this is our conclusive statement that would give you full marks. Now we have to sketch the curve for y equals f of x for for x is between 0 and pi, taking into consideration the relative values of the second derivative found in part B. Okay, so for C, you should be given a graph paper, but for now, I don't have a graph paper, so I'll just be drawing a rough graph. But you should be actually using a graph paper and making sure that all the points are actually valid and equal, okay? So our coordinates right now are 0, e, pi over 2, 1 over e, and pi e. So we just label our points here. Let's have E be here. 1 over E be here. And let's have pi over 2 be here. And I think that's relatively where pi should be. And we have a point right here, a point right here, and a point straight across right here. Okay, and we draw a line that connects these. Whoa. Okay, hold on. Accidentally pressed the button. All right. And that's not perfect, but you should be able to do it better during the exam. Make sure it is one line. Make sure you actually draw it with one line. All right. Next, we move on to D, which is find the Maclaurin series for cos 2x up to and including the term in x power 4. Now, this is where you can find it in your formula booklet right here. We can find our cos x in our Maclaurin series for special functions, but instead of cos x, we use cos 2x. So we substitute our 2x into the places where x are, okay? So it would be 1 minus 2x squared over 2 factorial plus 2x power 4 over 4 factorial. Keep in mind this is until the term x power 4, which is why we're stopping at that point. All right, and we would have 1 minus 4x squared over 2 plus 2 power 4, that's 16, x power 4, 4 factorial, 4 times 3 times 2 times 1, that is how much is that? 24. Okay. 24. Remember that this is a paper 1 paper, so you will not have a calculator, so make sure you do these calculations correctly. It would leave us with 1 minus 2x squared plus 2 over 3x x power 4. And that is our Maclaurin series for cos 2x. Next, we have hence find the Maclaurin series for e power cos 2x minus 1 up to and including the term in x power 4. Okay. E power cos 2x minus 1. So, we know that our cos 2x Maclaurin series is 1 minus 2x squared plus 2 over 3x power 4, right? So from this, we can actually, to get this value right here, we can just move 1 to the other side. All right, so we can do this. Cos 2x minus 1 is equal to minus 2x squared plus 2 over 3 x power 4. And by knowing this, we can move on to looking at the e power x Maclaurin series function here. So it is 1 plus x squared over 2 factorial. So we just do this. So our e power cos 2x minus 1 is equal to 1 plus minus 2x squared plus 2 over 3x power 4 plus minus 2x squared plus 2 over 3x power 4 squared over 2 factorial. And from here, we just simplify this further. We would get 1 minus 2x squared plus 2 over 3x power 4 plus we expand this. So we would have, okay, let's do this separately. Let's do this on its by itself. Let's do it here. So minus 2 x squared plus 2 over 3x power 4 times minus 2 x squared plus 2 over 3 x power 4. This would be, okay, this 4x power 4 plus, wait, minus, I mean, minus 4 over 3 x power 6. We just do this again, minus 4 over 3 x power 6 plus 4 over 9 x power 8. So we would get 4x power 4 minus 8 over 3 x power 6 plus 4 over 9 x power 8. But remember, when we look up, sorry, right here, we're only going up to and including the term x power 4. So our values here, 8 over 3x minus 8 over 3x to the power of 6 and 4 over 9 x to the power of 8 are not included. All right? So we just put our 4x power 4. And by knowing that, we just put 4x power 4 over 2, because 2 factorial is 2. Cancel this out, and we get 1 minus 2x squared plus 2 over 3x power 4 plus 2x power 4. And we can simplify this even further. So 1 minus 2x squared plus 2 over 3 x power 4 plus, let's just make the denominator the same, so it would be times 3, 6, 3 x power 4. We would have 1 minus 2x squared plus 2 over 3, plus 8 over 3x power 4. Okay, so that is our Maclaurin series for e power cos 2x minus 1. Then, for our last one, hence write down the Maclaurin series for f of x up to and including the term in x power 4. Okay, so this requires a little bit of critical thinking, because you do not want to do it manually. So we will just, okay, let's have this space here. Our triple I, we're trying to find the Maclaurin series for f of x, right? And so our f of x is cos e power cos 2x. Okay, so we know that e power cos 2x minus 1 can also be rewritten as e power cos 2x times e. All right? Times 1 over e, I mean. Am I right? Yeah, because it would be e minus 1, like this. All right, so to get f of x, we would have to multiply it with e. So e power cos 2x minus 1 times e would equal to our f of x, which is e power cos 2x, right? And by knowing that, we can find our Maclaurin series for e cos 2x, as it would be f of x equals to 1 minus 2x squared plus 8 over 3x power 4 from here, right here, and then times e, right? So we just multiply them together, we get e minus 2x squared e plus 8 over 3x power 4e. And that explains why this one Yeah, it's like you do not want to spend so much time with this, especially since it is a timed exam. Next, we have to use the first two non-zero terms in the Maclaurin series for f of x to show that the definite integral of e power cos 2x dx from 0 to 1 over 10 is just about equal to 149 e over 1500. All right, so for this, we need to remember that our first two non-zero terms here are this right here. So we'd have e, whoops, sorry. We have e and we have minus 2x squared e. Okay, so we just substitute that in there. 1 over 10, 0, e minus, let's look at that again, 2x squared e. 2x squared e dx. Next, we just integrate this. So we have open bracket ex and then minus 2x cube e over 3. And we have an upper boundary of 10 and a lower boundary of 0. So we just substitute 1 over 10 into the x values here. We get e 1 over 10 minus 2, 1 over 10, power 3 e over 3. So here we have, wait, sorry, I'll close that bracket there. We have e over 10 minus 1 over 10 to the power 3. We get 2, yeah, 2 times 1 over 1000, because 10 times 10 times 10, and e over 3. Multiply these and this together, so we get e over 10 minus 2e over 3000. Okay, next we just have to make the denominators the same. So we could do that by just multiplying this with 300. Okay, multiplying the numerator and denominator with 300. So we get 300e over 3000, sorry, minus 2e over, yikes, okay, 3000. Bro, I keep pressing the wrong button. Okay, so we have 198, not 198, 298e over 3000. What we're trying to find is, okay, this right here, okay? It's just about equal, it equates to 149e over 1500. So let's just divide it by 2, which is 149e over 1500. If you don't believe me, we can do this. And divided by 2, we get 1, 2, minus that, 9, 2. Wait, 4, I mean, sorry. 4, and then this would be 8, minus 1, 8, and this would be 9. Which is this. Okay, so that, yep. So this is the answer.